This is for 8.3, what is the effect on K if the reaction is written a different way? So if you have a new reaction and it's halved or doubled or reversed, how can you refer to an old reaction and work out a K value? So this is our original reaction that we're going to compare these two reactions to. It's nitrogen dioxide and dinitrogen tetroxide. So the first one, how are equations 1 and 2 related? So if you have a look, it's exactly the same reaction, just in reverse. It's just been written around the other way. So when we look at our K value, you can see that the products were originally the reactants in the other way it was written. So this has just been flipped over. So it's the reverse. The reaction is the reverse of the first one. So if the first one had a K value of 4.5, you could work out the K value for this one, this reaction. Any number can be read as being divided by 1. So this 4.5, it's the same thing as 4.5 on 1. You can see that you could treat this as the products, and you could treat this as the reactants. So the new K value, the reactants are now the products, and the products are now the reactants. So you've just flipped your expression over. So you put this 1 over 4.5, and if you divide 1 by 4.5, you get 0.22. moles to the -1. Okay, so the first rule, if the reaction is reversed, then you find the inverse 1 over the original K value. Okay, so the other one, this is our original reaction with our first original K value, which was 4.5, and this is the new one. So if you have a look at this reaction, it is exactly the same as the first one. It's just half. So we've got, instead of 1 here, you've got half, and instead of 2, you've got 1. So the whole thing is half of the first one. Alright, so it's half the coefficient. So what's the new K value? You can see that if this was 2, then you've squared it here. But if it's 1, then you've only put it to the power of 1. So it's the square root of this. So the second, K3, by the time you do that to all of the concentrations, the overall is going to be the square root of the first one. So if it was 4.5, then you find the square root of that. So it's 2.1. Okay, so rule 2, if it's halved, then you find the square root of the original value. So equally, if you had doubled it, then you would find the square of the original value. So the summary, if you reverse the reaction, then you flip it over because it's products on reactants, but if you write it the other way, then it's reactants on products. So the K value is like K on 1. So if you flip it over, it'll be 1 on K. So if the reaction is doubled, the new reaction is double of the old one, then you square the old one. If it's halved, then you find the square root of the old one. If it's tripled, you find the cube of it. If it's a third, then you find the cube, K to the power of a third. Alright, what is the equilibrium constant for this reaction? Given that the equilibrium constant for the reaction at 455 is 488, so the equilibrium constant for this reaction. So have a look at it and work out what's the difference between this one and that one. So hopefully you'll just see that it's the reverse, and it's also double. Oh, sorry, this is the original one, so this is half. So if we've got the original k value here, the original k value, then you're going to have to put it over 1 for the fact that it's reversed, and the one that you're working out is half of it, so you're going to have to square your original k value. So if we put the numbers in, our original k value was 48.8, so the new k is 0.143.